Hey! So we are continuing with computing definite integrals. So last class we introduced the fundamental theorem of calculus part 2, where we said suppose f of x is a continuous function on interval ab, and also suppose that the antiderivative f of x using the uppercase f that is the antiderivative for f of x. Then the integral from a to b, f of x dx, is the antiderivative of f of x from a to b. We can do the antiderivative f of b subtracted by the antiderivative f of a. So we are going to just do some examples together so that then you can work on some homework problems. So let's see, examples, computing definite integrals. Alright, so we'll do several of these together. Let's look if we're going from -3 to 1 for 6x squared minus 5x plus 2 dx. Alright, so I'm looking here, and on this interval there's no limitations. We can take from -3 to 1. There's nowhere where this is not going to be able to be found. So the first thing we want to do is find the antiderivative. So for 6x squared, remember you raise the exponent, divide by the new exponent. That would become 2x cubed. Then that would become minus 5/2 x squared. And then the 2 would become 2x. And we're going to do that on the interval from -3 to 1. So applying the fundamental theorem of calculus part 2, that means we take the antiderivative and substitute the 1 and subtract that from the antiderivative, substituting in the -3. So I'm going to show that quickly. Just substitute in, then substitute in for the lower limit. Okay, and so you would calculate in this first part for the antiderivative, substituting in the 1, that would give us 3/2 minus, then this becomes -165 over 2, and that gives us 168 over 2, which then is 84. Okay, so A would be 84. So now let's look at another example. So let's say we're going to go from 4 to 0. We have the square root of t times t subtract 2 dt. So now before I try to do this, personally, I would go and rewrite this. I know that the square root of t is t to the 1/2. So if I distribute the t to the 1/2 through, that would become t to the 3/2 minus 2t to the 1/2 dt. And that's much easier to find the antiderivative. So doing that, we want to find the antiderivative, and we're going to go 0 to 4. Now you could change put the 4 as the upper limit, but then you would have to take out a negative. It's fine to do. I'm going to substitute it in the way that I have it. So now for the antiderivative, t to the 3/2 is going to become t to the 5/2 divide by 5/2, which is 2/5 for the reciprocal, minus, all right, this 1/2 will become a 3/2. So then divide by 3/2, again, that's like multiplying by the reciprocal. So we would have 4 to the t to the 3/2 over 3. So we found our antiderivative, and now we can substitute. Remember, it's always the upper minus the lower. So that would be t to the 0, 5/2. Obviously, that's going to be 0. Again, this is going to be 0. So, I mean, if I wanted to, I could go ahead and write that as 0. Now here, we're actually going to substitute in 4 to the 5/2. Here to the 3/2. And so you're going to want, you probably for this one will want to use a calculator because it's got a lot going on. Just being honest. So doing that, I get 32 over 15. So 0 minus 32 over 15 would just be negative 32 over 15. All right. Let's look at another. So I'll do a different color so that it's easy to see as you look through the examples. Let's look from 1 to 2. We have 2w to the 5th minus w plus 3 divided by w squared dw. Okay, this is another one that is easier if we go ahead and simplify. I would divide each term in the numerator by the w squared. So for that first term, we would end up with 2w cubed minus w to the negative 1 plus 3w to the negative 2. Once it's in that form, we can easily take the antiderivative. And so we're going to do that on the interval 1 to 2. Remember, 2 is your upper and 1 is your lower. So finding the antiderivative, remember we increase our exponent by 1, and then that becomes what we divide by. So w to the 4th, if I divide by the 4, that 2 would go away and our denominator would be 2. Looking here at w to the power of negative 1, that gives us the natural log of w. And then 3w to the negative 2, when we take that antiderivative, the exponent's going to become negative 1. So we divide by negative 1. So that changes the sign, and we have minus 3w to the negative 1. So now that we've taken the antiderivative, we can do our computing. substitute the 2 in. Then subtract, substitute the 1 in. Okay, so looking at this, I don't want to lose my natural logs. So what I'm going to do is each piece, that 2 to the 4th divided by 2, that is 16 divided by 2, which is 8, minus natural log 2 minus the let's see, that minus 3 to 2. Okay, so that's going to become minus 3/2 minus this first term in the second is just 1/2 minus natural log 1 minus 3. Now, natural log of 1 is 0. So if I know natural log of 1 is 0, that is just going to be, we can put, add all of our constants. So we add 8 minus 3/2 minus 1/2 plus 3. So 8, 9, 10, 11, 11. Then that becomes subtract 2. So that's 9 minus the natural log of 2. So that would be your answer. Now, if you changed it, put it on the calculator, I would take a point or 2 off because it's not exact. You would be rounding probably. I couldn't imagine writing it all out, but this is the best way to write your final answer. Okay, let's look at, you had a problem similar to this a while back. It wasn't computing a definite integral. I'm pretty sure this was with an indefinite, and it was on a take-home assignment. But let's look at it again. Say we have the integral dr. So I'll look at this, and I know some people, I had someone email me, and they're like, is it 0 or is it 1? Well, assume that is a 1. So the antiderivative of 1, we're doing dr, so that would be an r. And that is on the interval from 25 to -10. So that's, you start with the b. So that's -10 minus 25, which is -35. So don't let it trip you up just because it had you didn't see, the 1 there, that constant. Okay. So that was working with a few problems. Let's look at a couple more that maybe have a little more going on with it. So let's look from 0 to 1. If we have 4x minus 6 cube root of x squared dx. So looking at this, the first thing I would like to do, hopefully you have been around long enough to know, I'm going to want to take that cube root out and write it as an exponent. So that becomes, the 4x is fine, and that's going to become 6x to the power of 2/3 dx. Okay, so now find the antiderivative. 4x would be 4x squared divided by 2, so 2x squared. That minus 6x to the 2/3, that would become x to the 5/3, and then multiply by 3/5. And so 6 times 3 is 18. And we're going to do the interval from 0 to 1. Then we substitute in. And then substitute in the 0. Okay. So that becomes 2 minus 18/5. And then all of this over here is going to be 0. All right, so 2 minus 18/5. So that's equivalent to 10/5 minus 18/5, which is negative 8/5. Now again, I know we talked last class. A lot of you would put put it in a calculator. That's okay, but make sure you do know how to, convert back to a fraction. Write your answer as a fraction when you're able. All right. Let's see. Let's do one with some trig. Let's see. All right, let's try. I'm going to do a new color. I just think it's easier when you're reading through the notes. But now I forgot what letter we were on. All right, so let's look at F. Let's do F. All right, so I said I was going to do a trig, but I'm not. I'm going to do, you'll see. So let's do the interval from -20 to -1. 3 over e to the negative z minus 1 over 3z dz. All right, so it is going to be so much easier if we just rewrite this. Look at that e to the negative z. Like, that's in the denominator, and it's a negative exponent. We can easily make that a positive exponent by just taking it out of the denominator. Then we can pull out the 1/3 in the second one and bring my z to the -1 dz. Okay? So we can go ahead and take the antiderivative. I did put the equals. So we say the antiderivative of 3e to the z is 3e to the z minus that 1/3 natural log z. And this is on the interval from -20 to -1. So we have 3e to the -1 minus 1/3 natural log -1 minus 3 e to the negative 20 minus 1/3 natural log negative 20. Okay, so from here, my 3, no, let me, oh, no. The 3e to the negative 1 doesn't have anything I can really do with that. And then minus 3e to the negative 20, I kind of want to go ahead and put those, clump my e's together. And so now I'm looking at my natural logs. So minus negative. All right, so we see they have the same, the 1/3 in front of the natural log. And we have the negative 20 and the negative 1. So we put those together. That would be plus the natural log of positive 20. Oh, I forgot the 1/3. I said it and I didn't write it. The 1/3 stays with it. And there we are. Now, some of us might would have just left it here, and that's okay. But I know that some of us like to really make things smaller. Okay. So let's do one more. And then I'll post your homework. So G. Let's go from negative 2 to 3. We have 5t to the 6 minus 10t plus 1 over t dt. All right, so before we start doing this, what you see here is you have a division, and our interval would include 0. So this integral cannot be done because there would be division by 0 in the third term at t equals 0. Now, if t equals 0, if there wasn't 0 in the integral, then we could, move forward. So, can not be done. Interval includes 0. Cannot divide by 0. Okay, so I'm going to get this posted. I do want us to look at some integrals, some piecewise functions, but we'll do that together. So I'll post your assignment. Y'all have a good rest of your day.